I welcome again all the students in the subject of computer graphics. Today we are going to learn, rather we are going to start with the second unit. Name of the unit is output primitives. Yes, we are going to start with the second unit, output primitives. The first point, underrated, scan conversion of point, line, circle and ellipse. Yes, we are going to learn how to draw the point, how we will draw the algorithm for line drawing algorithm, circle and ellipse. Okay. So the points under it that we are going to cover is Dda algorithm, then Breznam's algorithm. These are the two important algorithms for line drawing. Then we are going to cover midpoint algorithm for circle, or we say it as midpoint circle generation algorithm, and the same technique we are using for ellipse generation. So the point is midpoint algorithm for ellipse drawing. Okay. And in all this algorithm, okay, as it is mentioned in the syllabus, okay, we are going to focus on mathematical derivation above algorithm is expected. So we are going to consider that mathematically how the algorithm works, okay, or which is the different equation or the formulas used in this algorithm. So let us start the discussion. Now, all of you can look at the diagram that we are having is, okay, so we already learned this. Okay, generally, we are considering the CRT monitor display is always considered, or our monitor screen is always considered as matrix of pixels. Okay, so we always consider it as a matrix of pixel, but it is a discrete finite area cell. Okay, so these are, I call it as, these are the discrete, means these are the separate, means the, suppose I want to activate pixel 00, so obviously 00 is separate, okay, 1 is separate, 2 is separate, and so on. So these are the separate or discrete finite areas of the cells, area cells. So it is not possible directly to draw a straight line from one point to another. Okay, so I cannot draw or just drag it and draw it, but I need to activate all the pixels on the path of the line. Okay, so every pixel is separate and I have to activate all these pixels to draw the line. Okay, so it is not a continuous pixels, okay, but it is every pixel is separate and I have to activate it. Okay, so that is the reason, okay, for line drawing algorithm, okay, we have learned this, the process of or the process of determining which pixel. Okay, so we have considered as the process of determining which pixel provide the best approximation to the desired line. Okay, so which pixel gives the best approximation to the desired line, it is known as the rasterization. Okay, and we are going to learn, or we are going to work on the rasterization process. Okay, as we have to find out the best pixel on the path of the line. Okay, so before we are going to start with the DDA line drawing algorithm, okay, we have to consider the, whenever I am writing any line drawing algorithm, okay, so at that time I must consider the general requirements of the line drawing algorithm. Okay, so I'm going to consider here the general requirements of the line drawing algorithm. Okay, so now what is the general requirement? Okay, whenever I'm going to write down any algorithm or the program for the line drawing, the first and obvious thing that we are going to we want is the straight lines appear as a straight. Okay, I think whenever I'm going to underline this, okay, you can find it as the line I'm drawing is not straight. Okay, so what is the first requirement is straight line appear as a straight. I think this may be the line I'm drawing, but this is not straight line. Okay, it is not exactly straight. Okay, so my first requirement is this, straight lines appear as a straight. Second thing I want, the lines start and end accurately. Okay, so my starting point and ending point of the line must be accurate. It should not happen I start at the first point but I'm not activating the last point or end point. Okay, this generally happens, okay, because we may have 00, it is the address, this pixel is addressed at 00 at this position, but actually we are going to draw the 00th pixel will be, I am going to activate this complete circle. Okay, but it is addressed at this particular point. Okay, so this the another requirement is the line should start and end accurately. The next requirement is line should have a constant brightness. Okay, the brightness should be constant. Okay, it should not happen that some part of the line it is more brighter, some of the part the brightness is less. Okay, so what we are going to consider here is we are considering that the line should have a constant brightness, and then we are going to consider the obvious requirement of any algorithm or any program is it should be drawn rapidly. Okay, or my algorithm should be very fast and the line should be drawn very rapidly or very fast. Okay, or it will take minimum time, okay, to draw the line. Okay, so these are, we can call it as the general requirement. Okay, and it is applicable to all the line drawing algorithms that we are going to learn. Okay, or whenever you are writing, suppose being a researcher, if you want to write your own line drawing algorithm, okay, then you should consider all this. Okay, you should consider all these are the requirements of line drawing algorithm. Okay, so I want the straight line should appear straight, line start and end accurately, line should have this constant or same brightness throughout the path of the line, and then we want is it should be drawn rapidly, very fast. Okay, so with this background, let us start our discussion with what is mean by the DDA line drawing algorithm, how the DDA line drawing algorithm works. Now I think first we are learning what is mean by the DDA. Okay, generally this is also asked in so many objective questions. Okay, so what is the long form of DDA? Okay, so the meaning of DDA or long form of DDA is digital differential analyzer. Okay, so first D stand for digital, second D stand for differential analyzer. Okay, so it is based on the differential equation. Okay, so we are considering it as the digital differential analyzer. Okay, so is a scan conversion line algorithm, okay, which is based on either, or rather we can say by calculating the delta x value. Okay, so delta x nothing but we are calling it as the difference between the x2 and x1. Okay, if I consider my starting point of the line is x1 y1 and my end point is, okay, x2 y2, then the delta x indicate the x2 minus x1 or difference between the x2 and x1 point. Okay, and the delta y. Okay, so delta y is again considered in this case as the difference between y2 minus y1. So we are considering the difference between y2 as well as y1. Okay. Now this DDA line algorithm, it is equation, it is considered or it is based on the equation of the straight line, and we know what is the equation of the straight line is y is equal to mx plus c. Okay, so I am considering here that the value of y is considered as the m into x plus c. Here m is nothing but indicate the slope of the line. Okay, we are considering here the y value, y is equal to the point y is equal to m into x, where m is nothing but the slope of the line. And what is the value of slope of the line, or m is nothing but it is the delta y by delta x. Okay, so delta y is nothing but y2 minus y1 upon delta x is nothing but x2 minus x1. So it is nothing but it will consider dy by dx. Okay, so now plus and c, this will be obviously the constant value. Okay, now suppose I am knowing the first value of the line, or the any point is known to me, okay, on the path of the line, or maybe it may be the starting point of the line. Okay, now to calculate the next point means I am knowing what is the x1 y1. I know first point is x1 y1, so x value is known to me, y value of the starting point is known to me. Now I also know the x2 and y2, so I know what is the delta x and delta y. Okay, in that case it will be very easy to calculate the next point of the line. Suppose I consider my point, my current point is y of I. Okay, what is my current point? Y of I is my current point. To get the next point, I consider y of I plus 1. Okay, I plus 1 means it is my next point. So my next point is equal to y of I plus delta y. I just has to add the delta y into the current y value. I will get the next point. Okay, similarly on the x direction, okay, I get x of I plus 1 is nothing but x of I plus delta x. Okay, so x of I is my current point, plus I just has to add the delta x into it. Okay, so if I add the delta x, okay, in simple case, after knowing the x1 y1, if I add this delta x into the x current value, I will get next point. Similarly if I add this delta y value, if I add this delta y value in my current y value, or current y direction, I will get the next y I plus 1, or next y value. Okay, so now it may happens that as I'm going to write down the algorithm, first what I have to find out, I have to find out the in between delta x or delta y. What I have to do is I have to find out whether delta x or delta y, whichever is larger, whichever is large. So I have to find out whether delta x is large or whether the delta y is large. I have to choose between the delta x and delta y, whichever is larger, and I consider it as my one raster unit, or rather I consider that is my point to be used in my while loop. Okay, because my displacement, of the line, okay, if it is in the x direction it is higher, so I will take delta x. If it is y direction it is higher, then I will consider it as a delta y. Okay, so this is what we are going to consider, okay, initial stages, or this is the simple way how the DDA line drawing algorithm works. Okay, now we are with this, now we can in a position to go for the actual algorithm. Okay, so now we are moving to the next slide to learn the algorithm, actual algorithm. Okay, so this is what the algorithm which is given in our textbook. Now some of the thing which has mentioned in the algorithm as related to it is not exactly into the C language, but it is easy for us to understand. And in the second part of this lecture, we are going to also implement the algorithm through the C program or Turbo C editor, so that we are going to clear the concept, okay, so that we know how practically it can be implemented. Okay, so digital differential analyzer routine for rasterizing a line. Okay, now here these are the assumption. Okay, so I call this is my comment. Okay, in the comment what I have written, the line endpoints are x1 and y1. Okay, so x1 is and y1, this is my starting of the line, and x2 and y2, okay, this is my end point of the line. Start point of the line is x1 y1, end point of the line is x2 y2, and here it is written assume not equal. It is very obvious, if the starting and ending point are same, I think it will be only simple pixel. Okay, I will not draw the line. Okay, that's why they have written assume not equal. Okay, so x1 y1 and x2 y2 should not be same or should not be equal. Okay, now so x1 y1 is my starting point, x2 y2 is my end point of the line. Now in this algorithm we are going to consider one function that we call it as the integer function. Okay, we call it as a integer function. Now why integer function? Because in our calculation of delta x, delta y and the next point, okay, on the line, it may comes into the floating point. My answer may be in the floating point. Okay, so at that time, okay, what I need to do is I need to take the integer value of it. Okay, now the one note is mentioned here, many integer functions are floor functions. So what we are considering, suppose I am passing the integer value minus 8.5. Okay, my value I am going to pass with this is minus 8.5, then I will get this answer as the minus 9. Okay, anything which is there I will get minus 9 rather than minus 8. Means I am not going to remove directly the fractional part, okay, but I am going to I call it as I am going to make it floor. Okay, anything which is greater than 0.5 I will convert it to next value. If it is less than the value of, for example, minus 8 point something or 2 less than 5, I make it as a minus 8. Okay, so my answer is it is a floor. Okay, it is considered as a floor function. The algorithm assumes this is the case. Okay, so we have considered this, so we consider this at the time of the example also. Okay, so my integer function will not only truncate the value. If it is I'm just considering integer part, I will get minus 8, but no, we are not getting minus 8, we are getting minus 8.5. anything that is greater than 5, I will go to the next value of it. Less than 0.5 I will consider the previous value, so it will be considered as a minus 9. Okay, now along with this, as I am going to draw the line, okay, in the area, okay, where my starting point may be minus, okay, and my end point may be positive, it may be negative or it may be positive value. So we have having one function which we call it as the sine function. Okay, so this sine returns me the minus 1, okay, or it may return me the 0 or it returns me the 1 for the argument. if it is less than 0. If I am passing something to the sign and its value is less than 0, it will return me -1. Okay, so this is what indicate that I have to displacement is in the negative direction. If it is equal to 0, answer is 0. If it is greater than 0, okay, then my answer is 1. Okay, so this sign indicate that whatever the points I am drawing or whether I am going to increment it, okay, so I will say plus whatever the value I am doing, it may be incremented, it may be incremented. If it is +1, means I am going to increment the values. If it is -1, I am going to decrement the values. If it is 0, I am not going to increment or decrement. I am adding just 0 into it. Okay, so that's why we are having this particular sine function. So in this DT algorithm, okay, so this is what the part that was indicate or initial calculation indicate that I'm having x1 y1 as my starting point, x2 y2 is my end point. I'm having integer function, okay, so which will give me the integer value, okay, which is, okay, integer functions are floor function. Okay, so we are considering this as not only truncate the floating part, but you have to round up it, okay, round up to the next value. Okay, and then I'm having sine function which will give me return me the -1 value if it is less than 0. 0 it will return if it is equal to 0, and it is greater than 0, it is going to return me the 1. So it is just to know whether it is negative, it is equal to 0, or it is having the positive, then I will return the 1. Okay, this is used for the incrementing or whether it is decrementing. Okay, now we are going to first we have, as we have learned in the previous slide, what we have to do is we have to find out the largest value between delta x and delta y. Okay, so we are going to approximate the length of the line which is higher. Okay, so which is the length value that I'm going to take? I'm going to take between the absolute x2 minus x1 and absolute y2 minus y1, whichever is larger. Okay, so this x2 minus x1 is nothing but it is delta x, and this y2 minus y1 is nothing but it is delta y. Okay, so I'm going to choose between the delta x and delta y, okay, whichever is larger. Okay, so if x2 minus x1 is greater or equal to y2 minus y1, means x2 minus x1 is greater, what is my length? My length is absolute x2 minus x1. Okay, so I will get my length is absolute x2 minus x1, else the length will be y2 minus y1. Okay, so this is nothing but in this particular case what I'm going to do is I'm going to just take the largest value of delta x and delta y. Okay, so this is what the indication of the first thing that we have to decide the length of the line. Length is equal to whether the delta x or it may be equal to delta y, whichever is larger. Okay, so that we are going to assign. Okay, now moving to the next point, okay, in the algorithm. Okay, so here we can find the complete algorithm. Okay, now that is what we have considered here. Okay, now select the larger of delta x or delta y to be one raster unit. Okay, so I have to give which is the delta x and delta y value that I am going to calculate here. Okay, now here what is the delta x now? Now the value of delta x in this case is x2 minus x1 upon length. Okay, whichever is higher, that value is comes here, and delta y is equal to y2 minus y1 upon length. And what is length? We have already assigned the length is equal to highest or the largest of delta x and delta y. Okay, now generally this value that I am getting, it is comes into the fractional part. Okay, suppose in this case, suppose I considered here, okay, whatever the length, suppose I'm having is 3 value, x2 minus x1, suppose I get it as 2, so 2 divided by 3, I will get some point value in the floating point. Okay, floating point arithmetic. Okay, now whatever the point value I'm getting, I have to round the values, okay, rather than truncate. What I have to do is whatever the value I am getting, I have to round up these values rather than to truncate, so that center pixel addressing is handled correctly. Okay, so that is the reason what we are going to do here, or what is the thing that we are going to do in the algorithm is initially we go for x is equal to x1 plus 0.5 and y is equal to y1 plus 0.5. Okay, so why we are adding 0.5? The reason is suppose I got the value initially, okay, in my delta x and delta y. Okay, suppose I get whatever value, I am adding 0.5 into it. Okay, so suppose I get my initial point Okay, or suppose I am getting, means in this incrementing loop, okay, whatever the fractional part I am getting, I will get it as adding 0.5 to it. Okay, so initially suppose, or in any case, okay, I am just writing it here. Suppose my value is equal to 2.7. Okay, I am just writing it here. The value is 2.7. Okay, now in my function, if 2.7, what you feel what it should be considered? It should be considered as a 3. Okay, 2.7 should be considered as a 3. So what I'm going to do is I'm adding 0.5 into 2.7, so it will become a 3.2, and if I remove the fractional part, it will be equal to value considered as a 3 value. I get this value as a 3, so this 0.5 is added. Okay, so what we are going to do is we are going to add this 0.5 initially into the 2.7, or whatever the value of x1 and y1, so that I will get the round function, round up of the values that I will get. Another example, okay, suppose I get 2.1. If I add 0.5, it will become 2.6. So truncate, if I'm going to remove this, then also I will get only 2, okay, which is the correct answer. Okay, so that's why initially, so this is initially of the algorithm, we are going to add the 0.5 into x1, as well as we are going to add 0.5 into the y1. What is the purpose? Is to round out the value. Instead of truncating it, we are adding it. Okay, and this is our main loop start. Okay, so begin main loop. In my main loop, okay, what is my initial value of I? It should be 1. So initially I value is equal to 1. Okay, and now how much time this loop will be executed? What is the condition for termination of the loop? Is I is less than or equal to length. Okay, and what is the length? Length is the largest between delta x and delta y. Okay, so I just going to increment one by one. Every pixel I'm going to activate still the length. Okay, so what is the first thing that I have to do? I know what is my starting point of the line. What is my starting point of the line is x1 and y1. So what I'm going to do is, or in this case, my x1 and y1, by adding 0.5, it is stored as my initial point of the line x and y. Okay, this is my starting point of the line. So obviously I will set that pixel. So set pixel integer x and integer y. Now this is the statement integer x and integer y. It is going to activate that particular pixel. Okay, so it will activate the pixel x and it is going to activate the pixel y on the screen. Okay, that is my starting point, first pixel. Okay, now just now we have learned how to find out the next pixel. If I know what is my starting point x and y that I have activated also, what should be my next value? So my x of I, now we have seen the value x of I plus 1 is equal to x of I plus delta x. So in my initial value, I'm just going to add delta x. Okay, I will get the next point. In y of I plus 1 is equal to y of I plus delta y. So what is y is equal to? So I have to activate next point. So I just go for y is equal to y plus delta y. Okay, so just add the delta x into x and add delta y into y, so that we will be in a position to get the next point of the line. Okay, so I will get the next point. I is obviously incremented. Again, it will check whether it is less than length. No. If not, it will just put the next pixel. Okay, so it will activate the next pixel. Again, delta x is added into x, delta y is added into y. Okay, I value is incremented in the loop. Again, it will check whether it is less than length. If not, again the next pixel is activated. So this process or this while loop, okay, is going to continue. Okay, whatever the while loop that I am using here, this while loop will be continued till the end of the line. Okay, why it is end of the line? Because we have assigned the length is equal to the maximum of delta x and delta y. Okay, maximum displacement is considered. Okay, and it is going to activate all the pixels on the path of the line. Okay, so this is what we are going to consider. This is the algorithm that we are having. The actual algorithm, we know x1 y1 x2 y2 and all this, and this is what my main algorithm where I am going to go for it, or whether I am going to consider it. Okay, so this is what our Dda line drawing algorithm. Okay, very simple algorithm. Just we have to calculate delta x and delta y. Initial value is x1 and y1. Okay, I consider it as x and y. Okay, initially 0.5 is added to round up the values, and inside the while loop, my while loop will continue up to the length or maximum between the delta x and delta y. I just goes on activating the pixel. Starting pixel is activated. Add delta x into x. Add delta y into y. Get the next point. Activate that point, and this is continued till the end of the line. Okay, so which is a very simple algorithm, which we call it as, we can draw the line using the Dda line drawing algorithm. Okay, now whatever the algorithm just now we have considered, we have learned. Okay, so before, in the next part we are going for the its implementation through C program also, but I just have to put one example for it. Okay, the algorithm is very simple, but we just put the example. So in the next slide I'm just showing the on paper how I can calculate the value. Okay, so I'm just moving to the next slide to understand the example. Okay, so this is considered as an example which I have solved on the paper. You can solve this initially as a paper. Okay, now what we have to consider initially in this example is example number one. You can consider some different examples also. So initially I have taken very simple example. Consider the line from 0 0 to 5 5. Okay, my line is, I want to draw the line from 0 0 to 5 5. Okay, so what is my x1 in that case? X1 is 0, y1 is, okay, so this is my x1 and y1. Okay, x2 y2, my x2 value is 5, y2 value is 5. Okay, so I will get the x2 is equal to 5, y2 is equal to 5. Okay, now I will calculate the length. Okay, we have seen, okay, what is the length is, it is the difference, the maximum between delta x and delta y. So 5 minus 0, it is 5, both are same now. In this example, the delta x and, or we can say the y2 minus y1 is 5, x2 minus x1 also 5, and that's why I will get the value of length is equal to 5. Okay, length value is equal to 5. I am having the maximum displacement as a 5. Okay, then I will calculate delta x and delta y. What is delta x in this case? We have considered, okay, that is the value, okay, between, okay, we have considered as delta x2 minus x1 upon length. So x2 minus x1 is 5, 5 divided by 5, I will get the 1. Means I have to increment the x value plus 1. I have to increment the delta y also plus 1. Okay, because I'm moving from positive direction 0 0 to 5 5. If I'm moving from 0 0 to minus value, obviously this answer may be minus minus value or related to minus value. Okay, initially what we have done, x is equal to x1 plus 0.5. What is x1? 0. So 0 plus 0.5, I will get it as a 0.5. Y is also is equal to 0.5. Okay, so these are my initial calculation. Okay, so now incrementing through the main loop. In the main loop, what is going to happen? I declared I is equal to 1. Okay, then I'm having the next instruction is set pixel. Set pixel, I'm going to remove the integer part. So my initial value is 0.5, 0.5. Truncate this 0.5 because we have initially added this. So I will get 0 0. So which pixel is activated in this case is 0 0. X is 0.5, y is 0.5. Set pixel is 0 0. So this is what is indicated here. So I'm going to activate the pixel 0 0. My first point. Okay. Then incrementing through loop. I will check the condition here. Okay, whether my I value is less than length. No, I value is 1, length is equal to 5. So no, so the I is incremented. So I will get the I value is equal to 2. Okay, now in this case, in my initial loop, what I have done, what we are going to do in my while loop, okay, my x value initially 0.5 will be x is equal to x plus delta x. Delta x is nothing but it is 1. So 0.5 plus 1, I will get 1.5. Okay, 0.5 plus delta x, I will get it as 1.5. Y value 0.5 again, I will get y, delta y is also 1, I will get 1.5. Okay, so this is very simple example because the value displacement in x and y are same. Okay, again I will come back to the loop. I value is 2, I will activate the 1.1 pixel. So this particular pixel is activated. I'm going to activate this particular pixel. Okay, and again it is incremented. So this process is continued. This while loop, whatever I'm having, is continued until I'm having the value of I is equal to 5 because my length is also 5, and I'm going to check the condition in my while loop, okay, whether the I is less than length. Okay, so my I value when it will becomes 5, okay, I'm going to set the pixel 4 by 4. Okay, the pixel 4 by 4 is activated. 0 0 1 1 2 2 3 3 and 4 4. This is what is activated. Okay, and next line I'm having the value 0.5 and 5.5. But what is my I value? My I value becomes 6 here. Okay, when my I value is incremented and it is become 6, my condition fails. Okay, because in while loop I'm checking whether I is less than length. What is my length? My length is 5. Okay, my length is 5. So if I is 6, condition fails, I come out of this while loop. Okay, now you can find, this is a very simple example, okay, that how the DDA line drawing algorithm work, okay, or on paper we can calculate this. Okay, here I have shown that if I am going to activate 00 pixel, because it is address here, 00 pixel is address at this point, 11 pixel is address at this point. Look at this particular diagram. Okay, 22 is address here, 33 is address here, 44 is address here, and now you can find that if I consider 5 and 5, okay, you can find this is dotted here, means this is not activated. Okay, this pixel is not activated. Okay, this is not activated because this will become 5.5 will be 5, but my value is there. Okay, so my starting point is 0 0, end point is 5 5. Okay, and I'm activating obviously maximum 5 pixel here, that is 0 0 address here, 0 0 1 1 2 2 3 3 4 4 1 2 3 4 5, but this is not activated. This may be considered. So we will discuss this, okay, how this problem can be solved in the next algorithm as a when we move to the Breslum's line drawing algorithm. Okay, so this is what the example and the algorithm, very simple algorithm, only we have to calculate delta x and delta y. Okay, we have considered the slope of the line, and we add these values delta x and delta y into the initial or the current point, so that I will get the next point. Okay, so this is all about the DDA line drawing algorithm. Okay, next lecture we will see the same part of the lecture. We are going to see how it is can be implemented using the C programming. Okay, so that it will be more easy for us to understand, and then after that we will go for the understanding Breslum's line drawing algorithm. Okay, I hope all of you have understood it. Okay, very easy algorithm as a DDA line drawing algorithm. Okay, thank you.